In this example, it looks very similar to the previous one. But okay, let's read it together first of all. So the string row set shown in the figure was used to obtain normal string data at a point on the free surface. Again, free surface. Okay, what does that mean? Then determine the magnitude of absolute maximum shear stress at this point. Okay, the readings of the three strain gauges has been given, and the E and nu has been given. Okay, and the angles, you can also read the angles here from the sketch. Okay, in this example, we didn't provide steps, so you need to establish algorithm first of all, so how to solve it through how many steps. Okay, this but similar to the previous one, you can just since we're determining the tau max, we're determining tau max absolute, right? So how to find it? We need to define the stress states. Okay. If we know the stress state, you can analyze the tau max using the Mohr circle. The Mohr circle, right? So, but how can we get this the stress state? Okay, we can get the stress state from strain state. Here we will need to use Hooke's law. And how can we determine the strain state? Okay, what has been provided here is the results of strain row set. Okay. And it will just use this equation to achieve this step, the first step. Okay, so obviously the first step will be just use this equation to determine. So our first step will be to determine the sigma x, sigma y. Sorry, this we should be epsilon x, epsilon y, and gamma xy. Okay. Just here's a look at the three strain gauges, A, B, and C. Okay, so the strain gauges A is here. So theta equals negative 90 degree or 270 degree. Okay, the B here, theta B is 45 degree. Okay. And here the theta C equals 135 degree. Okay. Those are the directions of these three strain gauges, and their readings have been provided here. So you can just use this equation to solve the three unknowns. Okay. So at point A, the reading is negative 1,400, and epsilon x times cosine negative 90, so it will be 0. Okay, so here you actually just get 0. Right. Then plus epsilon y times 1, right? Then plus another 0. So from here you can directly get that the epsilon y equals negative 1,400 microstrain. Then at point B, the reading is 380. Then the first component will be epsilon x over 2 plus epsilon y over 2 plus gamma xy over 2 right? So this will be our equation 1. At point C, the reading is 620. Then the first component will be epsilon x over 2. Second will be epsilon y over 2. The third will be minus, okay, minus gamma xy over 2. This is our equation 2. Then this, you can see here you have a plus and minus in equation 1 and 2, so you can do sum, okay? Okay, just a 1 plus 2, equation 1 plus equation 2, you will get, on the left-hand side, you will get 380 plus 620, 1000 equals epsilon x plus epsilon y. Since you already know epsilon y, okay, epsilon y has been determined here, so use it to here, so you will be able to solve that epsilon x equals 2400 microstrain. Okay, then you can solve that gamma xy using either equation 1 or equation 2. I solve that gamma xy is negative 240 microradian. Okay, so now we have determined the strain states. Okay, the strain states here is epsilon x, epsilon y, and gamma xy. Okay, then we can do the second step. The second step is here, is to use Hooke's law. This is the first step. Second step will be using Hooke's law to calculate the stress states from strain states. Right? So the second step, strain to stress. Using Hooke's law. Right here, again, since it's a surface, so it's a plane stress. The equations will be the same as the previous example, right? It's sigma x equals E over 1 minus nu square epsilon x plus nu epsilon y. You will have, here's 17,000 KSI over 1 minus 0.29 square, 2,400 minus 0.29 times 1400. Okay, here should be plus, but since your epsilon y is negative, so you get a minus here. Okay. Again, do not forget one more thing. Right, what is that? What is that? We need one more thing here. Okay. Micro. Okay, microstrain. Let's highlight it again. Okay, do not forget this. The result here will be 37 KSI. Then you can calculate epsilon y in the same way. It's E over 1 minus nu square epsilon y plus nu epsilon x. Okay. Again, I will skip this calculations. You will get negative 13.1 KSI. Then the tau xy. Tau xy equals G gamma xy. Right? So the G in the same way, that's the G equals E over 2 times 1 plus nu. Okay, so you have 6590 KSI. So here just says 6590 times gamma xy. Gamma xy here, negative 240. Negative 240 microradian. Okay, so you will have negative 1.58 KSI. Okay, so here we have determined sigma x, sigma y, and tau xy. Okay, using these three things, you can draw more circle, right? You can draw more circle and then examine what is the tau max and what is the absolute tau max. Okay, then this will be our third step. Tau max. Okay, the tau max equals r, right? In the Mohr circle, the tau max just equals r. So we just need to determine the r. The r is just negative or positive. Sigma x minus sigma y over 2 square plus tau xy square. Right, so here it's 37 minus negative 13.1 plus 13.1 over 2 square plus 1.58 square. You get 25.1 KSI. Okay, so this is the radius. Okay, this is the radius or the tau max. This is the in-plane tau max, right? But will the absolute tau max larger than this value? We need to do a double check. It's possible that they equal to each other, or they do not equal to each other. It depends on do the two plane stresses have the same sign, right? So we need to double check it by calculating the two principal stresses. Okay, to do double check, we need to calculate the two principal stresses, P1, P2. Okay, just center plus or minus r. The center will be sigma x plus sigma y over 2 plus or minus r. Okay, here's the average value. The center will be these two. Plus them together over 2, you get a 24, about 24 over 2, 12, plus or minus 25.1. Okay, so they're approximately the sigma P1 is 37. And sigma P2 is negative 13. Okay. You can see that they have different signs. Okay, they have different signs, meaning that sigma P1 times sigma P2 smaller than 0. What does that mean? What does it mean? That means your tau max absolute equals tau max in plane. Okay, so that is still 25.1 KSI. Okay, so how about if they do not have, if they have the same sign? So if sigma P1 is 37, then sigma P2 is 13. So how about in that way? If they have the same sign, what is the absolute? The absolute max shear will be the largest one, the larger one in these two principal stresses over 2. Okay, this recall the previous principles and the rules.